First of all, I need to apologize my cough. Had a COVID 2 weeks ago and apparently survived, but this kind of coughing comes from time to time, but I'll try to manage, so just that you know. But yes, I'm Joni from Biomed, and actually this is the Biomed stage because we are the sponsoring of this stage here. And I wanted to present you with an R&D journey, because I was thinking how to unpack this, what I'm about to do. And for myself, whenever coming to conferences like this, I always like to know about the new products and understand what's in it. But in many times, some products might be just listing ingredients, or they may be somehow other so advanced that I don't really get the point. Why is it so different? So I know there are also people here who are in the business and on the R&D, so developing new products as well. So I'm going to talk about little about liposomes and liposomal delivery combined with some other exciting stuff. So there might be takeaways for even the people who are developing products themselves. And for the rest of us, it's just an interesting look behind the scenes of a new product which was specifically made for this event, from biohackers to biohackers. So, R&D journey. Well, as I mentioned already. So our R&D journey starts with this guy. And this here is a phospholipid. Let's have a guess. Who knows what's a phospholipid? Raise hands. Yeah. Well, phospholipids are the main building block of oral cells, specifically the cell wall. So every cell in our body is having a cell wall which is made of these phospholipids. What we see here is a phosphate head and an oil or fat tail, which means that the phosphate head is hydrophilic and the tail is hydrophobic, which means the ball here, it loves water, and this phobic part is afraid of water. So this is the basic construction piece of our cell wall. If you have like soy lecithin or sunflower lecithin or any other lecithin which has like phosphocholine or eggs, for example, when you make an emulsion or make mayonnaise in your kitchen, what happens when you put phospholipids in free water solution? They spontaneously form themselves in a way that the the hydrophobic tail doesn't have to touch water, so they form micelle. And as you can see there's this phosphate group is facing out, it's facing the water, and tails, which are fat, they are facing inward. And it's not like the pie, like here, this is like cut in half, it really exists in a ball form. So this is something that happens spontaneously if you just mix lecithin with water. But then, now we go to the next one, which is many have heard about liposomes. So this is like a bilayer structure. And what it means is that now this is more usually man-made. So we have this lecithin in the water, and then we apply quite a high forces in the solution, like high sharing forces, that it's being torn to all directions, and it tries to all the time reconfigure itself to avoid touching the water. And when done properly, we form liposomes, which means that there is this amount of water inside. And these are very interesting compounds. We'll get to them just in a second. The third one, or fourth one, is phospholipid bilayer. Now this actually represents pretty much our own cell wall structure. And these also have been existing spontaneously, and it is one theory that these early liposomes that have been floating in the oceans have maybe functioned as like the pre-versions of cells for, to be protected from the outside environment and to be able to, let's see if I can get back to this inside water there, it's protected from the outside sources. So It is one theory that that's where cells came from. But yes, so this is the phospholipid bilayer, and here is our cell wall. Much cooler picture, huh? So again, we have the phospholipids over here, and they make the entirety of every cell we have. And these blue things, they are some other cell organelles, and they are, for example, controlling what gets in the cell and what gets out of the cell. But yeah, these are pretty much the building blocks of life. And yeah, and one reason why the liposomes are so interesting here is that when you have some nutrients packed in a liposome and it gets contact with this kind of structure, they are so similar that they actually, the cell just accepts the liposome and ingests the content. A healthy cell can also reject the liposome or exchange contents with the liposome. So it is always, the last word is on the cell, but because the structures are so similar, the liposome just kind of goes in the cell without effort. So because when we know that many times like curcumin or other very cool and very healthy ingredients, they have low bioavailability. That means that cell wall doesn't accept them maybe, but in the liposomal form they just go in. So that's why it's important. So liposome as a carrier and how to load it. This is kind of nerd stuff, but maybe you like it. Here's a better picture of liposome. It's again cut in half. Really, you cannot cut in half liposome, because if you would, it would just rearrange itself instantly into a new liposome. But here we have the hydrophilic heads and hydrophobic tails, and there is this nutrient load. So when you make liposomes, let's say you have like soy lecithin or sunflower lecithin, which has high amount of phosphocholine, which is the usual phospholipid. And let's say you have a very strong vitamin C liquid. Like you have so much vitamin C that it cannot take any more. So it's like saturated liquid of vitamin C, very astringent and very high vitamin C content. If you mix it with phospholipids like this and then apply the required force, the required force is usually ultrasonics, so you need to sonicate with 1,000 kilohertz, 20,000 kilohertz to kind of aggressively shake the liposome. And when it rearranges itself into a liposome, it traps the surrounding liquid inside. And it just happens that this liquid here has an immense amount of vitamin C dissolved. So when you use liposomal vitamin C, your cells want these liposomes. They accept them very readily, and while they're doing it, they also get the vitamin C. It's like also almost like a cheat. So, and these are very cool. For example, I had one researcher who's researching cancer. He was telling me about that, okay, we could load like messenger RNA in a water-soluble form and have the messenger RNA in there, and then we could decorate this liposome with antibodies. And that means that your immune system will take this specifically to the cancer tumor and make the tumor like susceptible for other treatments. And that's the high-tech stuff, and the pharmaceutical industry is using liposomes, has used them for decades already. So it's a technology well known. But in the supplement form, it's recently been more available. So now we enter something which is only biomed stuff. And what are neurolipids? Well, it's a 40-year-old thing. There has been production of for 40 years already, but it actually was, the inventing started 1972. So it's that old thing. But these guys who are in the screen, Karla Jaakkola, medical doctor, and Raimo Hiltunen, professor of pharmacognosy in Helsinki University, I consider them as the original gangsters in nutritional therapy in Finland. So these are the guys who did it before it was cool. Like Karla, who's the founder of Biomed, has treated thousands and thousands of patients with very difficult things going on when other treatments have failed. And Raimo Hiltunen, he's passed already, but he was a figure that both the pharmaceutical people and the supplement people both respected. So he was a giant figure. So I'm just standing here on the shoulders of the giants. But yeah, about neurolipids. It's an animal-based phospholipids, and it's isolated from nerve tissue. So it's not your usual soy lecithin or sunflower lecithin, but it is from nerve tissue, animal-based. And what it means, it is, of course, purified, concentrated, and it only contains the phospholipids, the omegas, the EPA, the DHA, all this, the whole lipid profile that exists in your own brain. And thus, well, if you think you are eating liver capsules or organ meats of animals, let's say heart, kidney, you know that if you are using them, the organs of mammals, they will fortify your own organs. They will make you healthy. So this is just basically the same thing. But this is not whole food, but it's like a very concentrated, purified, like medical grade stuff. So it was originally to be a drug-like nutritional intervention in cases of severe cell damage, like neurological damage, like diseases. People have been treated with neurolipids for 40 years now, and we have a very good track record on the results, and it really works. Because it is like targeted nutrients for your own nervous system and all the cells that might be suffering from, like, let's say cancer, you have an intensely high oxidative stress that's bombing every cell. Then when you take neurolipid as a treatment, you will get like new materials to build and rebound your cells from that stress. Contains all the fats and phospholipids for neural repair. And for example, something like this. Well, phosphatidylcholine you can find in eggs as well, and soy lecithin and all the lecithins. But then these are these very special ones like sphingomyelin, cerebrosides, cardiolipin, and the exact omega-3, 6, 7, 9, and EPA and DHA ratio that you have in your own brain. So it's really, really different. But here is actually one quote. Raimo Hiltunen, the professor guy, he was famous for speaking so advanced sentences that nobody could understand a word because he was going like so high. But he at least once wrote something that we can understand. And it's this. Administered orally, these phospholipids are absorbed from the small intestine, cross the blood-brain barrier, actively seek into nerve cells, and because they contain the proper mixture of fatty acids, including EPA and DHA, they enhance the membrane fluidity of receiving cell wall. So that's what makes the neurolipid so special. And I cannot overstate how this guy knew what he was talking about. Next one on our R&D journey is lion's mane. How many knows lion's mane? Good. If you don't, you should. It's a medicinal mushroom which is best known for enhancing cognition. So, well, there are other benefits as well, but let's stay with the cognition now. It is studied for neuroregeneration, Alzheimer, Parkinson, depression, memory enhancement, and nerve repair. And it is because it contains these are just two compounds, erinosins and hericenones. And well, this guy over here, that's lion's mane, of course. And the hericenones are found in the fruiting body, the part you can actually see. And the ericenins can be found in the mycelium, which is kind of the roots of the mushroom. But this book has not, the last page hasn't been written. We only started to research what everything there is, because there are so many compounds that stimulate NGF, neural growth factor, and BDNF, which is the brain-derived neurotropic factor. So you can see very intense results with lion's mane. It's like it is not directly NGF, but it stimulates your own production. Yes. Well, here's the thing. It's best yielded with ultrasonic extraction. We can use ultrasonics for the liposomal formation, But this is one reason that mushrooms have very hard shell. Then if you just make your like ethanol water extract, you can only extract so much, not really much, because most of the stuff will be held inside the chitin shell of the mushroom. Also, if you directly eat the mushroom, most of it will just pass through you. But you need to use ultrasonic extraction, which is like, it's by sound, basically. You have water, alcohol, and you have this 20 kilohertz of pounding sound hammering out the nutrients to the extract. And this is why I want to mention that we are using Kappa Health, or Kappa Biotech, or Kappa Mushrooms. Eric actually will be speaking right after me. He's the CEO. But this lion's mane we use is an organic lion's mane grown in Finland in their top facility, and then ultrasound extracted and purified, and that's what we use. But I just want to shout out for their quality. I think they are also here. So some studies, what lion's mane does, they are just few, because there are many studies going on. But in 50 to 80-year-old Japanese men and women diagnosed with cognitive impairment, lion's mane improved cognitive function. And this was clear. There was a placebo group, and it was very clear that it helped. And this was done in 2009. Then footnotes has the links. Other one, lion's mane promotes nerve regeneration after limb injury in rats. Now we enter kind of the area of, is it right to hurt animals? But my friend was in a car accident and his spine was injured, and I tried to look for some things to help regenerate. And I found this study, and it's a long study, I really checked it out. What happened, they did cause the rats, there was anesthetics, so they were not like hurt, but they basically destroyed some peripheral nerves of the rats, and they started limping. The other group got lion's mane extract, the other group didn't. But the group who did get just like a lion's mane tea, it wasn't even a very powerful extract, they regained their, basically it grew back the peripheral neuron and they stopped limping. So this is quite something. Well, and another one, in a 4-week human study, menopausal symptoms such as loss of concentration, irritability, palpitations, anxiety significantly decreased when treated with lion's mane extract. This alleviation of some symptoms also improved sleep quality. And again, we are talking about full spectrum extracts. We don't need to go like isolate erisinins and herisinones and stuff, because we really don't yet know what's making all happen. I think it's the whole complex of lion's mane. There is this intelligence in all the mushrooms. And this is maybe very interesting. This is one of the pictures I love. Now, there is nerve cells, and in the top left, there is just nerve cells without any stimulation. And the top right, there is NGF, so synthetic nerve growth factor in there, and they have been incubated for 48 hours, so 2 days. So nerve growth factor really makes the nerve cells to grow. But these 4 pictures on the bottom are lion's mane extract in a dose-dependent ratio. So what we see here, let's see, for example, the last picture on the bottom right. It's insane. It's 48 hours of having these nerve cells in lion's mane liquid. They are like taking off. And of course, this is in a Petri dish. So if you are, like Olli said in the first day, that if you are a test tube, then you might use spirulina for some condition, because sometimes you can only have results in test tube, and you don't know do they really function as well in humans. But that's why we come to the last phase. Now we have talked about liposomes, and then not just any liposome, but neurolipids. And now we have this stimulating compound, lion's mane. So I call the combination the spark and the wood. So you have the spark, the stimulant, which is the lion's mane, and you have the wood, which is the building blocks. So how do we put it together? First, there is emulsification, which means we emulsify our neurolipids with water to have like this liposome base, and then we emulsify further with the lion's mane purified extracts to make this fat complexes with the lion's mane. What this does is that because these neurolipids, they selectively target your nervous system, your brain, and now we have the lion's mane in there like a passenger, then we get to have the both in the same address at the same time. Now, there is something that you need to have here to protect this very delicate substance from your stomach acid. So we have a high purity whey protein isolate, and why? Is because it has the high beta-lactoglobulin content which resists your stomach acid. Whey protein doesn't dissolve in your stomach acid, only in the small intestine. So when we freeze dry this liquid, what happens is that the whey protein makes a nice shell for this fat complex and protects it until it's in the small intestine, where it's opened and it dissolves and gets to your small intestine, like bloodstream, and directly to your nervous system. So that's the whole thing, and how it looks is this. I think it's kind of biohacky looking product, and it was really made for this occasion. And if you want, you can have yours at the Biohacker Center stand. They are at sale in there. And of course, you can later on visit biomed.fi for discounts, and it will be shipped worldwide. So yes, and if you want to reach out, ask me about the product or anything, that's my email, you can take a picture. Thank you very much.